Section 6.3 volumes with shell method. So last time we did volumes, but we used disk and washer methods. Here we're going to learn a third method that would make things easier for us in some cases. And before we show you that method, let's look at an example from last time. Let R be the region bounded by the graphs of y equals x and y equals x squared. Find the volume of the solid obtained by revolving R about the y-axis. First, we draw the diagram, label everything. This is y equals x squared, and then we have y equals x, y equals x. So this is the region where one talk about revolving about the y-axis. Revolving about the y-axis. Now, I'm gonna draw, based on last time's notes, we're gonna draw a rectangle perpendicular to the axis of revolution. So that tells me dy. So the volume is pi integral is gonna be dy, something square minus something else square. And if you set the two equations equal to each other and factor and solve, you would get x equals 0 or 1. So they intersected at 0 and 1. From 0 to 1. And then we need the outer radius minus the inner radius. The outer minus the inner. So this is the outer radius. This is the inner radius. And what is that? That's x on the y equals x squared. So we need to solve for x, which is the square root of y. So that would be square root of y. And the small r is this x on the y equal x, but x equals y. And then from here, if we do the integral, calculated, this is y minus y squared dy. I'm sure everyone can calculate this. When you do so, the answer will be pi over 6. Now, with shell method, that's when we're going to use cylindrical shells. And what do we need to know about shell method? When we find the volume, we use 2 pi instead of 1 pi. The integral, say from A to B. 3 things. 1, we call it the average radius. 2, length of the rectangle. 3, the thickness. I'll explain all of that in a minute. So for the thickness, that's usually dx slash or dy. Length of the rectangle, usually it's f minus g, something like that, like the upper minus lower or right minus left. The average radius is the distance from rectangle to axis of revolution. One thing about the shell method, unlike what we did last time, the rectangle that we construct, the rectangle must be must be parallel to axis of revolution. Let's take the same example we just did. So I'm gonna draw the same one we completed, the y equals x squared, y equals square root of x, and this was the region, and we are rotating about the y-axis. So remember, the rectangle must be parallel to the axis of revolution. So it's gonna be like this, a vertical rectangle. That tells me it's a dx. So watch how I'm gonna set up the integral. We use shell method. And the shell method says you do 2 pi integral. You know, that rectangle is moving from 0 to 1. 0 to 1. 3 things. Here I know the last one, the thickness is dx. The height of the rectangle, or the average radius first. Average radius is the distance from the rectangle to the axis of revolution. This is the average radius, which is an x distance from the y-axis. That's the average radius. We have the next one is, beside the average radius, the length of the rectangle. The length of the rectangle is gonna go this minus this, right? So this is the y equals x minus the y equals x squared. And then if you do the work, you should get the same answer as before, pi over 6. Let's take the same problem, just add the same thing. If we are rotating region R about a different axis, instead of y-axis, say x equals -2. Try to set it up using both washer and shell methods. So I'm gonna redraw the diagram again. This is the y equals x squared, and this is y equals x. This is the region, and I'm gonna rotate around x equals -2. Say it's here, that's the vertical line, the axis of revolution. If you want to use, let's say, washer first, like last time, it would be, the rectangle would be perpendicular, like that. So I have a dy, pi, again, 0 to 1. Something squared minus something else squared. So that would be this minus this. So let's see, the whole thing, it's 2 units plus the x of x squared, which is square root of y, minus 2 plus y. But with shell, let's see, with shell method, the volume would be 2 pi 0 to 1 dx in this case, because it's going to be parallel. Like that. So 2 things we need: the average radius, which is the distance from the axis of revolution to the rectangle, and that would be the 2 that we have plus the x. So 2 plus x. And the height of the rectangle, we found earlier, x minus x squared. I think the shell method in this case, to finish it up, it's much easier. How about if we look at part C about x equals 5 as another example? X equals 5. Try to do both shell and washer just for practice. Alright, let's take a look at it. Again, we need to draw the diagram. This is y equals x squared. This is y equals square root of x, not x. And we're rotating this around x equals 5. Say it's here. So this means we can do both methods. If I want to use washer, I do perpendicular rectangles. So with washer, it's going to be the volume is pi integral, again 0 to 1. We're going to have dy square square. So this distance from here to here, it's 5 minus x. So 5 minus, but that x associated with y equals x. So x is y. The other one is this to this, 5 minus x squared or square root of y. Shell method. Volume is 2 pi integral 0 to 1. Three things. We're going to have a vertical rectangle like that, dx. So dx goes in here. The height of the rectangle is x minus x squared, and the distance from the axis of revolution to the rectangle, it's this distance from here to here. What is that distance? Well, this is 5, the whole 5, minus the x. 5 minus x. Now, we can move on to one other example, a different example. Say the region bounded by y equals x squared and x equals y squared. And we're rotating this about, say, about y equals -1. Set up the volume, and we will do another one, 2x squared minus x squared and y equals 0, rotated, this region rotated about y-axis. So for this one, we have y equals x squared and x equals y squared. This is the region. We're going to rotate this around y equals -1. This is y equals -1. And the origin. So if I want to use, we can use either method, shell or washer. Either one is fine. But if, let's say, we want to use what we learned today, something new, let's see how we approach that. So with shell method, we're gonna have the volume. The volume is 2 pi integral.
Pastor, you said.
The rectangle must be parallel to the axis of revolution for shell method. So I have a dy here. Dy. So how am I gonna find the rest of them? The first thing, this. What is this? That's a 1 plus y. 1 plus y. But this y, What is it? Just a y distance. We don't change anything with it. So just 1 plus y. 1 plus y. And this still goes from 0 to 1. If you set them equal to each other. If you set the y equals x squared and x equals y squared, substitute the y in. Factor x out. You get x 0 or 1. For the length of the rectangle, how am I going to find that? I'm going to take the outer radius, like this distance, minus this distance. So the one from the y-axis minus the one closer to the x-axis. But everything inside has to be in terms of y. The further from the y-axis is y equals x squared. So we have to solve for x. Everything has to be in terms of y. Minus the one closer to the x-axis, that's x equals y squared. So that's what we have. To go to y equals 2x squared minus x cubed and y equals 0, taking about y-axis, we have to sketch this. x0, y0, x1, y1, x2, that's 4 times 2, 8, minus 8, 0. So it's gonna go up somehow like that. I care about this place because this is y equals 0. So it's the region between the graph and y equals 0 around the y-axis. So if we try to use washer method, it's not going to be easy to use or almost impossible. So only shell method will work. So how is that going to work here? The volume is 2 pi for shell. So we have the rectangle parallel to the axis of revolution, dx. That dx is going from 0 to 2. The length of the rectangle is just the graph itself, minus 0. The distance from here to here is simply x. There's nothing to write there. And we assume everyone can complete this. You are welcome to integrate this right now and share the answers. So here is what we have is the reason it's better to, you can't use the shell washer method, because if you draw again the figure like that and it's around this, you need to draw the rectangle perpendicular to the axis of revolution. So it's going to be like this, which is dy. So if you want to set this up with washer, you're going to do pi integral from, I don't know, 0 to some place, and then you're going to do this minus this. What is this? We don't know what that is. Like, you can't use the actual equation curve. Same thing on that side. I don't know what that is. So that's why we have to use shell method. Even if you don't know from like minute one, hey, which method should I use? Should I use this method or that method? If you don't know, it's okay. You try it and then you find out like, wow, I stuck on shell method. I need to go back to trying shell. I stuck on washer. I need to go back to shell method. 4.